Well, so far we've talked about covalent bonds and ionic bonds. We even talked about different varieties of covalent bonds, but now it's time to talk about hydrogen bonding. Just for clarity, I'm calling it hydrogen bonding instead of hydrogen bonds because it's a different sort of thing. Whereas covalent bonds hold together molecules themselves. They knit together the atoms, kind of like knitting together sort of the fabric of a shirt. Hey, hydrogen bonds are more like that. They're more like this static cling. There's like an attraction between the sock and the shirt, just by a static cling, but it's easily removed. So it's a different sort of attraction between two things, two different molecules. Let's explore it just a little bit. Now, hydrogen bonding is a result of obviously hydrogen atoms that have a partially positive charge to them. If you remember before, we've talked about this covalent bond being a polar covalent bond, that electrons are pulled this way, leaving that hydrogen ion somewhat positively charged. Well, that charge can create an attraction. So if there's a negative charge out here, there's going to be this attraction between that hydrogen and whatever this negative charge is over here. This is hydrogen bonding. And just because it's a weak force of attraction doesn't mean it's not important. Let's look at a few examples. Hydrogen bonding is immensely important to water. So here's a whole bunch of water molecules. Notice a lot of these OH bonds. These are going to be those lopsided polar covalent bonds. And that means that all the hydrogens have a somewhat positive charge and the oxygen somewhat negative charge, which sets up these attractive forces between every hydrogen and oxygen on different molecules. So between this water molecule and this one, there's an attraction here, as well as here and here and here and here, and it really starts to add up. And this is partly why water sticks together. It's cohesive. You can even fill up a water cup until it's over full because of that hydrogen bonding between these. It holds the water together. It also makes it a little sticky. It likes to stick to other things a bit. There's that attraction between water and other polar molecules. So this hydrogen bonding in water, really important to many of the unique properties of water itself. There's also what makes water a great solvent for so many other polar and ionic compounds. So salt, sodium chloride. The chloride ions can break up and they're attracted to these positively charged hydrogens, and the sodium attracted to the oxygens. So water's a really good solvent as well. And this goes a little beyond hydrogen bonding, but it's an outgrowth of that. Maybe a little more relevant is glucose over here. See all these OH groups, the hydroxyl groups on glucose? Well, they're going to have those same imbalanced bonds as well. There's going to be an attraction between the hydrogens and the oxygen, so more hydrogen bonding there. Again, making it a good solvent. It's also really important when it comes to proteins and DNA and their structure, but there's a little more than I can draw here, so let's take a look on the big screen. So here we can see a protein structure, and all these little dotted lines here and over here are the hydrogen bonding between amino acids, which are shown as these little purple beads. And so it's an important part of their structure, holding proteins in just the right shape to do their job. Same is true of DNA. While most of the DNA is held together by covalent bonds, and we know that there are two strands, one here and one here, and these nucleotides are complementary. If we look at the detail over here, we see the hydrogen bonding, these dotted lines again between the nucleotides on the adjacent strands. And so it holds DNA strands together, but not so strongly that they're impossible to pull apart and use the DNA. Hydrogen bonding provides almost a good life lesson. I mean, these are weak, attractive forces, but because there's so many of them, they really add up into something that's significant. And we can't underestimate their importance in life. But it's kind of like for us, alone we may not be able to do much. But when a lot of us unite, then there's power. That's it for this time. Until next time, remember, life is good.